Hello. Okay, so here is my lab 8. As you can see, I'm gonna start off by just importing all the packages and all that I need from their libraries, and then I specify that I'm gonna be using my assigned data set, which is bank data set, and this is how it looks originally. And I'm just gonna go ahead and pick for the x variables to be age, balance, and p days, so just 3, and then my y that I'm going to be trying to classify is education, so that is the only categorical variable, and then the rest are numeric. And age. And right here I go ahead and I want to separate the education column from the rest of I'm sorry, I'm specifying that this is what I'm going to be trying to predict by calling that the train labels. And over here I'm separating it to be my Y, and then I'll see everything else is still going to be the bank. So, and then I'm going to split it up here. So the test size is only 20, the 20%, and the training is 80%. And then I'm go ahead here, and we're going to print how our train labels look, just because we want to make sure that we got the dummy this like sparse matrix over here, and as you can see that does all look good. And then we do go ahead and normalize our training set for the x. That just goes ahead and make sure it actually applies it, so that all looks good. We do see that we did normalize it. And then over here we're actually building our function, so we see I'll go down here and explain because I wrote it out that the model expects rows of data with 4 variables, so the input is dimension of 4, and the first layer has 12 nodes and uses the ReLU activation function. The second hidden layer has 8 nodes and uses the ReLU activation function as well, and then that outer layer has the 4 nodes and uses the softmax activation function. So that all matches what we have here. And we just obviously call for the summary just to see what it's looking like. Over here you can see that we did just compile that model, so we're obviously doing our loss and categorical. So because we do want that, we're predicting something that's categorical, our variables categorical, and then our optimizer, and then the metrics we want accuracy. So when we run the model, it runs fine, and we can see the accuracy over here. It does have an accuracy of about 0.5-ish. And then over here, 0.5, yeah, that's about value accuracy. And then over here, just printed out how my X test looks like, how my Y, I turned the Y test into an array. We have our Y train, this is our X train, that's how that looks. We have the, I was trying to do the evaluation, and then, so this will be my predicted. And my Y predicted, I went ahead and turned that into an array. And then, as you can see over here, I tried to turn that into the dummies, but that didn't really work perfectly. And I kept getting errors. And the reason I printed out all of these, the heads of the different X trains and Y trains, is because I wanted to see why I was getting all the errors with accuracy score, as well as the confusion matrix and the classification report. But I know that's something that me and Professor Struber have been back and forth about, and unfortunately we were unable to figure that out. And because of that, I'm not completely sure how we could, I guess, compare and contrast the results of this model in our output to the one of Lab 6. I would assume that because this is a deep learning, that this would probably be more accurate than the Model 6, just because, like I said, it has more layers. And yeah, that would be my prediction.